Can I load your brain onto a computer? No. No supercomputer in the world can store or process that much information. However, this may be possible in the near future with quantum computers. To understand this, we have to go back and look at one revolutionary invention, the transistor. The transistor is the basic building block of computers. Essentially, a transistor is a switch. All it does is turn on and off. When a transistor is on, you can label it as a 1. When it is off, you can label it as a 0. These 1s and 0s are what make binary code, and a large collection of transistors is what builds computer chips. A 1 or a 0 is considered a bit, and there are 8 bits in a byte. Bytes are what make up data on a computer. Now, what if I told you that we could go even smaller than a bit? What if I told you that there was such thing as a transistor that could be on and off, 1 and 0, at the exact same time? Enter the quantum bit or qubit. The qubit is the base of quantum computing because it can be a 1 and a 0 simultaneously through a concept called superposition. However, when we observe it how we desire, it becomes what we see. Let me explain it with that rock. That rock is on the ground over there, but what if I told you the exact same rock was also in my room right now? Same rock, same time, different locations. I'm not looking at the rock, but now I will. I just turned around, and I can still see the rock on the ground. However, I will no longer be able to see the rock in my bedroom. Let's repeat this experiment again, but this time, I'll go up to my room. I can see the rock in my room, but now I will no longer be able to see the rock on the ground outside. This is how a qubit works. When you observe a qubit through a specific filter, it'll collapse into the state that you want it to be. Let's look back at the classical bits. With 2 bits on a regular computer, you can make 4 different combinations of numbers. However, you can only use one of them at a time. With 2 qubits on a quantum computer, you can choose to use all the combinations at once. We can use this property to model the exponential function f of n equals 2 to the power of n. You can see with this model that only 30 qubits is equivalent to over 1 billion classical bits. This is revolutionary. A team of engineers in California constructed a quantum computer and fed it a long list of seemingly random numbers. The computer was given the task to find the correlation of numbers through regression. This is a task that would take the most powerful supercomputer in the world over 10,000 years to compute. The quantum computer did it in 3 minutes and 20 seconds. Quantum computers will allow us to render complex simulations and solve strenuous math equations. It's only a matter of time until these machines are perfected. When, and only when the day comes, we may be able to load a brain onto a computer.